know what a skeleton is by now, the types of skeletons, flexors, that kind of thing. I'm not too concerned about that, but let's look at the differences in these muscles. All right, what are some of the things that we need to know? Well, we know that there are primarily three types of muscles that we see in the animal kingdom. We see skeletal muscle, we see smooth muscle, and we see cardiac muscle. All right. Make sure, I don't want to spend a lot of time on this tonight because I think this is something that's relatively straightforward, that you know the actual ways in which these muscle types are similar and ways in which these muscle types are not the same. Okay? So in other words, you can field questions like that. For example, of the three muscle types, which ones can generate their own action potential? How many can generate their own action potential? Without receiving an action potential from your nerves. How many? There are only two. What are they? Cardiac and your smooth. Remember, skeletal muscle does nothing unless stimulated by what? Your nervous system. Okay? Keep that in mind. All right. So make sure you understand those kinds of differences. Here's another difference. Just throw this out. Does smooth muscle have sarcomere? In other words, are the contractile units in smooth muscle organized into sarcomeres like we see in skeletal muscle and loosely in cardiac muscle? Are they? No, they are not. It's one of the reasons why cardiac and skeleton are often associated with what we call striation. All right, remember that's fictitious under the microscope. Smooth muscle does not have striation. It does not organize its actin and myosin into contractile units. That's one, but that has to be that way. The smooth muscle not only contracts like this, but it contracts like this as well. All right, skeletal muscle is just one way, up and down. That's it. So the point is, if you want to move something all around, like your stomach does, or your alimentary canal, you've got multiple contractions in 3 dimensions. If you had something wrapped up in this deliberate thing called a sarcomere, end to end to end, they wouldn't be able to do that. You'd have to run them in all different directions. So there's another key difference between cardiac muscle, skeletal muscle, and smooth muscle. All right, so again, pick up on those. Think about how the muscle contracts and that kind of thing. All right, so enough of that. Let's move into the next piece then. Well, if we look at the skeletal muscle, which is a classic example of how it contracts, all right, and the reason why we do this is because this was relatively easy to figure out. Smooth muscle guys, we still don't know. Okay, I'm not exaggerating here. I'd love to spend a whole semester on it, but I can't. It's just, we still don't know how smooth muscle pulls off what it pulls off, because the fibers are not aligned in regular ways. I could show you some schematics and you'd be like, whoa, it's all over the place. It's still out there. And so it's much easier for us to look at organized fibers. It's easy for us under research conditions to in other words, modulate this, to actually set it up to model it. So that's why we tend to know a bit more about striated muscle than we do about smooth muscle. But that's it. All right? Basically, ultimately, we must get to what we call the contractile unit. In other words, the sarcomere. So we got to go